Hello students, today I am going to take the chemistry topic, especially the laws of chemical reactions and how chemical reaction can be represented, what are the laws involving chemical reactions, and all these things you should know, because chemistry, of course, a mystery topic, and you should know what are the chemical reactions going on around us. In our everyday life, we are using lot of compounds which are related to a branch of chemistry, especially organic chemistry, inorganic chemistry, physical chemistry. So everything is under chemistry. So everyday life we are acquainting with a lot of material we are using in chemistry. So that's the importance of chemistry we are going to discuss today. So we'll see the first question here given is which of the following is a chemical reaction? Let me tell you what is a chemical reaction. A chemical reaction is a process in which some substance combine to give some new substance. The substances which are combining are called reactants, and the products, the new substance formed, are called products. So reactants combine to give products known by the name chemical reaction. The physical and chemical property of reactant and products are entirely different. That's why we call it a chemical change. We have seen melting of ice. Melting of ice is H2O, solid, and the water is also H2O, but we can't call it a chemical change because it is a physical change. But at the same time, here we have a lot of examples given. First one is rusting of iron. You are familiar with the rusting of iron. If you piece a nail open in air, it reacts with the moisture, it reacts with the oxygen of the air to form rust. And what is rust? Rust is Fe is iron that react with the oxygen of air, and water drops to form Fe2O3 dot XH2O. So this is rusting of iron. This is called a rust. So rust has the name hydrated ferric oxide. Hydrated ferric oxide. So it is an example of a chemical reaction. And second one is formation of curd from milk. And milk contain a sugar called lactose. And curd is, so lactose converted to lactic acid. Lactic acid is 2-hydroxypropanoic acid. So this is another chemical reaction. So lactose is a sugar and this is an acid. So that is another chemical reaction that is going on. So for fermentation of formation of curd from milk, we have to keep the milk in the air because of the action of bacteria. The lactose, the sugar present in the lactose will, lactose is the sugar present in the milk that get converted into lactic acid. So lactic acid is carboxylic acid. The formula of lactic acid here is CH3 CH ZOH. So this is lactic acid. This is a carboxylic acid containing hydroxyl group. So it is another example of chemical reaction. And fermentation of grape juice. Grape juice contains sugar. And what's sugar? Sugar is sucrose. Sucrose is C12H22O11 that get converted into ethyl alcohol. So that is another example. So the third one is sucrose. Sucrose is present in grape. And the sucrose has a formula C12H22O11 and it get converted into ethyl alcohol, that is C2H5OH. So these are the examples of chemical reaction. So here, which of the following is a chemical reaction? We will see the first one. Rusting of iron is a chemical reaction. Formation of curd from milk is another example of chemical reaction. Fermentation of grape juice. If you keep the grape juice contain sucrose or sugar. Grape juice, pineapple juice, or whatever the juice you are keeping in air for 2 or 3 days, it will undergo fermentation and the product formed will be ethyl alcohol, carbon dioxide, and some water will be there. It is a very dilute solution of ethyl alcohol. So it is ethyl alcohol is forming. So that is another chemical reaction. So a chemical reaction is a process in which a material or a substance converted into a new substance. The substance that is being converted is called a reactant and the new substance is called products. The reactants and products are different in composition, different in physical and chemical property. That's why we call it a chemical reaction. Okay? Yes. And the next one is the balancing chemical equation follow. Balancing chemical equation. We'll see hydrogen. I will get you an example. Hydrogen combined with the oxygen to give water. Hydrogen combined with the oxygen to give water. So here 2 hydrogen, there only 1 oxygen. So here you have to put 2 So now oxygen is balanced, and here hydrogen we have to balance for 2. So this is the equation: 2 into 2, 4 hydrogen, 2 into 2, 4 hydrogen, O2, O2. So the balancing equation is based on law of conservation of mass. Law of conservation of mass or matter. The law was given by Anthony Lavoisier, and the law states that total mass of reactant will be equal to total mass of the products, or mass of the substance or reacting substance will be equal to mass of the substance that is being formed. So total mass of reactant will be equal to total mass of the product. And we have another statement also: matter can neither be created nor be destroyed. It can be converted from one form to another form. So this law is called the law of conservation of mass. Based on this law, we have to balance the equation. And next is the law of conservation of energy. It is an entirely different. Energy can neither be created nor be destroyed, and it can be converted from one form to another form. This is a normal statement that we are always saying from lower classes. There is a new statement. It is impossible to construct a perpetual motion machine. It is impossible to construct a perpetual motion machine. The meaning of the word perpetual motion machine is a machine that can produce energy without using any form of energy, and it is not possible. Imagine you are going to construct a machine, or you are going to construct a generator, and when the current goes on, you are switching on that machine, and it produces current. No fuel you are adding, no petrol, no diesel, nothing, no kerosene. And if such a machine is prepared, that machine has a name: perpetual motion machine. We can't prepare such a machine. So it is impossible to construct a perpetual motion machine. So that is a law of conservation of energy. And another normal statement is energy can neither be converted from, and energy can neither be created nor be destroyed. It can be converted from one form to another form. So you can have one energy, it can be converted into another energy. You are putting some fuel in the generator, it will produce electric current. If no fuel, no current will come out. So that is the second one. And Mendeleev periodic law you will study. Mendeleev is Dmitry Mendeleev was the person who created the first periodic table, and it has the name Mendeleev periodic table. And in that table he stated that the properties of elements are periodic function of atomic weight. Periodic function of atomic weight. As atomic weight changes, the property of element also changes. That is Mendeleev periodic law, and this is modern periodic law. So modern periodic law was given by Henry Moseley, and he stated that the properties of elements are periodic function of atomic number. Atomic number can be taken as a primary standard. As the atomic number of the element changes, the property of element also changes. That is modern periodic law. And based on this modern periodic law given by Henry Moseley, a group of scientists, the name of the scientists are Bohr, Berry, Rang and Werner. Bohr, Berry, Rang and Werner. They have arranged elements in horizontal rows and vertical column, and that arrangement is called a long form periodic table or modern periodic table. So modern periodic table is based on modern periodic law. So here for this question the answer is law of conservation of mass. So balancing chemical equation is strictly based on law of conservation of mass or matter given by Anthony Lavoisier. The third question is stoichiometry equations are called. What is meant by stoichiometry? Stoichiometry means balancing the chemical equation. Balancing the chemical equation is called stoichiometry. So here I will get you magnesium burned in oxygen or combined with oxygen. The product is MgO. So here you have to balance. Oxygen is 2, so here you have to put 2, and here also 2. So here I have taken 2 moles of oxygen, and it requires 1 mole oxygen, and the product formed will be 2 mole. 2 mole. So this is called stoichiometry. The stoichiometry is a number given in front of the element. In front of the symbol for the element, we give 2 moles of magnesium combined with 1 mole of O2 to form 2 MgO. So this is called stoichiometry, and this is called a balanced equation. This is called a balanced equation. So I will get you another equation also, one more example. You are going to burn CH4. CH4 is methane. Methane gas is burned in oxygen. The product will be carbon dioxide plus water and heat. heat will be liberated, because methane is a major component of natural gas. You are familiar with the natural gas. You may have heard about natural gas. Natural gas existing in two forms. One is CNG and the other one is LNG. CNG is called a compressed natural gas. LNG is called a liquefied natural gas. So natural gas contain methane, ethane, propane, butane, pentane. But the major component of natural gas is methane. You are going to burn natural gas, and in air, oxygen. Air is oxygen. So we will see, here you have 4 hydrogen, here only 2 hydrogen. So you have to put 2 here. So we will see the number of oxygen here. Here you have O2, here 2. So total 4 oxygen. So here you have to put 2 oxygen. So 2 into 2, 4. So see the equation. Carbon 1, carbon 1. Hydrogen 4, hydrogen 4. Oxygen is 4. Here 2, 2. So this is called a balanced chemical equation. So balanced chemical equation is called a stoichiometry equation. Here 1 mole of methane require 2 mole of oxygen for complete combustion. So that is called stoichiometry. So the combustion require a required amount of oxygen. 1 mole of a substance burn in required amount of oxygen. Is called enthalpy. In that process, some heat will be liberated. That heat is called enthalpy change or enthalpy of combustion. And whenever you burn any material, heat will be liberated. So normally the enthalpy of combustion is always negative. The negative sign shows exothermic reaction. So whenever you burn any material in required amount of oxygen, some amount of heat will be liberated. So the process is exothermic. Process is exothermic. So here the answer is balanced equation. And the next question, what does the symbol, this symbol represent? This symbol actually represents gas. So I will give you some example. You take zinc, you are putting it in hydrochloric acid, and the product formed will be ZnCl2 plus hydrogen. So hydrogen is normally existing in the form of gas, so it should be noted like this. So this symbol, hydrogen with this symbol, represents gas. So gas is liberated. Okay, so zinc react with the hydrochloric acid, the product is hydrogen gas. Another example is same aluminum react with the NaOH concentrated on heating, the product is NaAlO2 plus hydrogen gas. So hydrogen gas will be liberated. So this is one important, these are the methods for preparation of hydrogen gas. That will be familiar to you when you study the topic hydrogen. When you study the topic hydrogen, there are around 15 methods of equation for preparation of hydrogen. They are the general preparation, and later you will study more about the industrial preparation of hydrogen also. So industrial preparation and normal general preparation, around 20 methods you have to study. When you study in the topic hydrogen, you will be familiar with all these equations. So this symbol, the upward symbol represents gas and downward symbol represents precipitate. So downward symbol represents precipitate. I will get you another example. ZaOH twice. This is called lime water. Lime water. You pass carbon dioxide gas. The product will be ZaCO3 plus water. And CaCO3 is called precipitate. So downward symbol represents precipitate and the upward symbol represents gas. So downward symbol represents precipitate and upward symbol represents gas. So this is the answer of this question. So please look into the question. What does this symbol, the upward arrow, represent? It liberation of heat, evolution of gas, evolution of light, precipitation. So here the answer is evolution of gas. So it represents the liberation of gas. The upward symbol always represents the liberation of gas and downward symbol always represents a formation of precipitate. Formation of precipitate. So here I have given you the calcium carbonate, CaCO3. When you pass carbon dioxide gas through lime water, you will get a precipitate, a white precipitate. So precipitate is normally represented by a downward arrow and the gas is normally represented by an upward arrow. The equation calcium carbonate plus XNO3 giving CaNO3 twice plus YCO2 plus H2O, the value of X and Y. Actually this is we have to balance the equation. Here we are going to balance the equation by putting values for X and Y. So how will you do this? We will see. Calcium carbonate treated with the XHNO3 giving CaNO3 twice plus CO2 plus H2O. So we'll see. We'll remove the X here, and later we will. So we'll see how here calcium is here you have only one calcium, so here also only one calcium, so calcium is balanced. Here HNO3, so NO3 is only one, but here NO3 is 2, so here we will put a 2 here. So what happens? 2, we'll see 2, so 2HNO3, CaNO3 twice, then water H2O is there, here 2H, then carbon dioxide here C, and there also NO3, so here answer is one carbon, and here also one carbon. So here the answer is Ca, calcium, carbon, oxygen 6, here 2 3s are 6, 6 plus 6 12, so here 2 3s are 6, 6 plus here we have 6 plus 2 8, 8 plus 1 9, so here we have to put carbon dioxide also, so here the answer is 2 and 1. 2 and 1. Let me see once again. The calcium, one calcium here, one calcium here, one calcium here, and carbonate CO3. So carbon is 1. Here carbon is 1. Oxygen is 3. Here 2 3s are 6. 6 plus 3 9. So on the other side 2 3s are 6. 6 plus 2 8. 8 plus 1 9. So the equation is here you have to put CaCO3 plus 2HNO3 give CaNO3 twice plus CO2 plus H2O. So now the entire equation is balanced. So calcium, carbonate CO3, one carbon, here one carbon, and here 2H, nitrogen 2, oxygen 2 3s are 6, 6 plus 3 9, so here 2 3s are 6, 6 plus 2 8, 8 plus 1 9. So left hand side, all the atoms on the left hand side and right hand side are balanced. So here the stoichiometry for nitric acid is 2 and carbon dioxide is 1. So here we can give the answer as 2 and 1. So option is C is option. So like that, please look into the number of atoms on the left hand side and number of atoms on the right hand side. So they should be made equal, then the equation will be balanced. And there are so many techniques for balancing an equation that you have to study in a topic called the redox reaction, a half equation method and oxidation number method, so that you will study in your future topic. So that's the way in which we have to balance a chemical reaction. And the balancing chemical equation is based on stoichiometry, and it is based on law of conservation of mass or matter. And next one is Na plus 2Na plus Cl, 2Na, sodium xylate combined with the chlorine gas. The product is 2NaCl, xylate. This is an example of, we'll see the first one, combination reaction. Second one is decomposition reaction. Third one is displacement reaction. And fourth one is double displacement reaction. So this is an example of a combination reaction. This is an example of a combination reaction. Two elements combine to give a compound. That is called a combination reaction. Decomposition reaction means a compound on heating decompose to give two different products. It is called a decomposition. You take calcium carbonate and on heating it will give calcium oxide plus carbon dioxide. Calcium oxide plus carbon dioxide. So this is an example of a decomposition reaction. Decomposition reaction. And third one is displacement reaction. What is displacement? I have told you, you can displace a magnesium combined with a hydrochloric acid. The product is MgCl2 plus hydrogen. So hydrogen gas comes out from HCl. So it is an example of a displacement reaction, and hydrogen comes out as gas. It is represented by an upward arrow. Okay, and the next one is double displacement. Double displacement means two double displacement or double decomposition we can give. See, you take a Na2SO4 plus barium chloride. We have see this chlorine comes and Na goes to the other side, 2NaCl plus barium sulfate. So these are the examples of the various types of options given. The first one is example of a combination. So here sodium combined with chlorine is an example of a combination reaction, and decomposition means a material decomposed to give a new product on heating. Here I have to, this symbol represents heat. This symbol represents, triangle represents heat. So product is calcium oxide and CO2. CO2 is a gas. CO2 is a gas, and this is displacement reaction. So magnesium combined with HCl, MgCl2 and hydrogen gas, it is an example of displacement reaction. And this one is a double decomposition reaction. So two materials changes, Na2SO4 become NaCl and the barium chloride become barium sulfate, because the anionic part was exchanged between these two reactants, and you are getting the reactant is completely changed. Na2SO4 become NaCl, barium chloride become barium sulfate. And the next one, N2 plus 3H2 giving 2NH3. The given equation is an example of. Actually, the name of this reaction is Haber process of ammonia. N2 plus 3H2 reversible 2NH3. Here you have 1 mole nitrogen. Here you have 3 mole of hydrogen and 2 mole of ammonia. The number of mole is different, but the mass is equal. Here 2 mole, 1 mole nitrogen means 28 gram. 28 gram, and here it is 6 gram, here it is 34 gram. See, the total mass of reactant is 34 and total mass of product is also 34. So this is an example of decomposition reaction. No. Single displacement, no. Double displacement, no. This is a synthesis reaction, because we are going to synthesize ammonia. We are going to prepare a new material. So the reaction is called a synthesis reaction. So ammonia is synthesized or ammonia is manufactured. Ammonia is prepared by using this reaction, nitrogen combined with hydrogen. And name of this process is called Fritz-Haber process. Fritz-Haber process. Fritz-Haber process. And in this process, the energy liberated is delta H minus 92 kilojoule. Minus 92 kilojoule energy liberated. The negative sign shows exothermic. So this is an exothermic reaction. This is a synthesis of ammonia, known by the name Fritz-Haber process or simply Haber process. Because normally the students will study it as a Haber process. The actual name or the full name is Fritz-Haber process. And the next one, ionization of water is an example of. Ionization of water means hydrogen H2O changes to H plus and OH minus, and OH minus will again change to give oxygen and hydrogen. And this process is called ionization of water. This process is called ionization of water, displacement reaction, combination reaction, oxidation reaction, decomposition reaction. So this is an example of a decomposition reaction. Decomposition reaction. Because water split to give hydrogen as well as OH, and OH will again split to give hydrogen and oxygen. So finally you will get hydrogen and oxygen. So we call it a ionization of water, or we can say water will split into positive and negative ion. In water we have two ions, H plus ion and OH minus ion, and that step we call ionization reaction. So ionization reaction is an example of decomposition reaction. And I will see which of the following equation represent combination of two elements. Combination of two elements. In the first one, not an element, calcium oxide combined with carbon dioxide, CaCO3. So this is a compound, this is a compound. So they are not elements. But in the second case, 4Na. Na is an element, O2 is an element. On heating it forms 2Na2O. Na2O. This is called sodium monoxide. Sodium monoxide. So this is a compound formed by combination of two elements. So here the answer is option B. In the third one, SO2 is a compound, O2 is a element. So SO2 combined with O2 to give SO3. But so they are not a combination of two elements. it is a combination of compound and element. And here Na combined with water, NaOH and hydrogen. That is also a displacement reaction. Sodium is a metal and it is an element. It combined with water. Water is a compound. So an element combined with a compound to form NaOH and hydrogen. Hydrogen is liberated as gas. So it is not a combination of two elements. So here the question is, which of the following equation represents combination of two elements? So here the answer is option 2. Option 2 is the answer. And next one, the reaction in which two compounds exchange their ions to form a two new compound. What is it called? Displacement reaction, decomposition reaction, addition reaction, double displacement reaction. Double displacement reaction. So we have an example called, you take a NaCl treated with the AgNO3 solution. NaCl solution, AgNO3 solution. The product formed will be NO3 comes here and you will get NaNO3 plus AgCl precipitate. AgCl precipitate. So these are the, so actually what is happening, the ions are exchanged between the two reactants. So Cl minus goes to the other side, NO3 minus goes to the other side. So Cl minus comes here, so you get a new compound. The compound is NaNO3 and AgCl. So such a reaction is called double displacement reaction. Double displacement reaction, or the ions are exchanged between, or we can call double decomposition also. So double displacement reaction. So we will get a precipitate of AgCl, and AgCl is a white curdy precipitate. Actually we use this equation for testing of chloride ion. Testing of chloride ion, Cl minus ion in a given solution can be tested by using this equation. By adding AgNO3, you will get a white curdy precipitate of AgCl. AgCl is having white curdy precipitate, and along with NaNO3, NaNO3 is soluble in medium, but AgCl is insoluble in medium. So that is why you get a white curdy precipitate. So it is an example of double displacement or double decomposition reaction. And the next one, which of the following equation is not an example of electrolysis? Then what is electrolysis? Electrolysis is you are going to pass current through molten salt or an aqueous solution of any salt. That salt will displace or hydrogen at cathode and chlorine at anode, hydrogen at cathode or oxygen at anode if it is a very dilute solution. And if you are taking NaCl fused means NaCl molten state, and you are passing current by using some electrode, the sodium metal will come and discharge at cathode, and a chlorine gas will come at anode. So such a reaction is called electrolysis, or we call it electrolytic reduction. So for this, the substance should pass current through it. So such materials are called electrolyte. So here we will see what is electrolysis. First one, water on electricity, we will get water, electricity, hydrogen and oxygen. Second one, NaCl molten, electricity, Na and Cl. So this is an example of electrolysis. This is another example of electrolysis. We will see next one, CaCO3 solid on heating in a furnace. So this is not electrolysis. This is called thermal decomposition. Thermal decomposition. This is an example of thermal decomposition. And Al2O3. Al2O3 is called alumina. It is dissolved in molten cryolite, and on passing current, aluminum will discharge at cathode and oxygen will discharge at anode. And that is also an example of electrolysis. So the example of electrolysis are, first one is example, because when you pass current through water, hydrogen gas will liberate at a cathode and oxygen at anode. Like that, when you pass current through molten NaCl, the product will be sodium at cathode and chlorine at anode. And actually this method is called, this method was developed by Humphrey Davy, extraction of sodium, and that cell has a name, down cell. And last one, Al2O3, on passing current you will get aluminum and oxygen, and that method was developed by two scientists, Charles Martin Hall and Paul Héroult. So this method is called the Hall-Héroult process, extraction of aluminum. So aluminum is extracted by electrolysis of fused alumina in molten cryolite. The product is aluminum at cathode and oxygen at anode. So all the A, B, C are example of electrolysis, and A, B, D are example of electrolysis, and C is not an example of electrolysis, and C is called thermal decomposition. Then barium chloride react with Na2SO4. The product is BaSO4 plus NaCl. Above reaction is, I will write the equation. A barium chloride solution that is given as aqueous. Barium chloride solution plus Na2SO4. Na2SO4. The product is BaSO4 precipitate. BaSO4 precipitate. So precipitate is represented by a downward arrow plus 2 NaCl aqueous. So here what is happening? SO4 comes here and chlorine goes to the other side. And that is an example of a double displacement or double decomposition reaction, because the two reactants are decomposed to give two new products. So because the anion is exchanged between the reactant, SO4 2 minus comes to this side and chloride ion goes to the other side. Other side means other reactant. So the anion are exchanged between the reactant and it is called a double displacement reaction. Next one, acid-base reaction is called neutralization reaction. Acid and base. Acid plus base in aqueous medium combine to give salt aqueous plus water. This is an example of neutralization. So neutralization is a process in which an acid combined with the required amount of base in aqueous medium to give salt and water is called a neutralization reaction. So I'll give you two examples. HCl aqueous plus NaOH aqueous. The product is NaCl aqueous plus H2O. So this is an example of neutralization. Hydrochloric acid combined with the sodium hydroxide solution to give NaCl and water. So this is an example of a neutralization reaction. Another example is you take HNO3 aqueous plus KOH aqueous. Aqueous means a dilute solution. The product is KNO3 plus water. KNO3 plus water. So this is another example of neutralization. So neutralization is a process in which an acid combined with the required amount of base or a base combined with the required amount of acid in aqueous medium to give salt and water is an example of neutralization reaction. So here the answer is neutralization reaction. And the next one, which of the following is not true with respect to neutralization reaction? Salt is formed, it is true. So salt is formed, it is true. Second one, reaction occur between an acid and a base. That is also true. Third one, it is a double displacement reaction. Reactants are in gaseous state. Of course, this is a double displacement because HCl combined with we will see the equation. HCl combined with NaOH, OH comes here and Cl goes to the other side. So of course, it is an example of a double displacement reaction. Reactants are in the gaseous state. That is false. Reactants are not in the gaseous state. So that is a false statement. So answer is option D. What happens when zinc react with the hydrochloric acid? Actually, this is a general equation for the preparation of first general method for the preparation of hydrogen. Zinc solid react with the hydrochloric acid, HCl acid. The product formed will be ZnCl2 plus hydrogen gas. So gas is forming. So I have given upward arrow. So here the answer is the gas formation. Here the answer is gas formation takes place. The gas is forming. And instead of this zinc, you can use magnesium also. Magnesium plus H2SO4 also. The product will be MgSO4, and this is dilute acid is enough. MgSO4 plus hydrogen. MgSO4 plus hydrogen. So this is another method for the preparation of hydrogen. Okay, so the gas formation. In the process of burning magnesium in air, magnesium undergo. See, magnesium ribbon or magnesium solid burn in oxygen. The product is 2MgO. This reaction is called oxidation. Because in elemental state, the power of element is 0. But when it becomes MgO, oxygen gets -2 and this gets +2. So here what is happening? The number is increasing from 0 to +2. So we call it oxidation. If number is decreasing, so it called reduction. Here 0 to -2, we call it reduction. So magnesium is having oxidation and oxygen is having reduction. So here the question, in the process of burning magnesium in air, magnesium undergo oxidation. Oxidation is, there are so many definitions. Addition of oxygen is called oxidation. Addition of electronegative element is called oxidation. Removal of hydrogen is called oxidation. Removal of electropositive element is called oxidation. So, but reduction is the reverse of all these things. Addition of oxygen is called oxidation. Addition of electronegative element is called oxidation. Addition of electronegative radical is called oxidation. So here magnesium become MgO, so oxygen added, so we can call oxidation. Then 4NH3 plus 5O2, 4NH3 plus 5O2, the product is 4NO plus 6H2O. This is an example of 4NH3. NH3 is a gas, oxygen is a gas, this is also a gas, and this is a liquid. So this is an example of first one displacement reaction, second one combination reaction, third one is redox reaction, decomposition reaction. This is an example of a redox reaction because ammonia get oxidized to NO. So here this is having oxidation and here it is having reduction. So this is an example of redox reaction. A redox reaction is a reaction in which one reactant has oxidation and the other reactant has reduction. So here ammonia get oxidized to NO and oxygen get reduced to water. So ammonia oxidation, it undergo oxidation and oxygen undergo reduction. Okay, so this is an example of a redox reaction. Then a redox reaction is one in which both reactants are reduced, both reactants are oxidized, or an acid neutralized by base. One substance oxidized while other get reduced. So this is a definition for a redox reaction. Redox reaction is one reactant has oxidation, other reactant has reduction. This is called a redox reaction. And I will tell you one more additional point. At the same time, if one reactant has oxidation and reduction, at the same time one reactant has oxidation and reduction, we call it disproportionation reaction. Disproportionation reaction. So I will get you an example for disproportionation reaction. Is this: you pass chlorine gas through NaCl or NaOH dilute. The product is NaOCl plus NaCl plus water. So here chlorine in the elemental state the power is 0. But when it becomes NaCl, it is -1. So here what happens? The oxidation number decreases. So we call it reduction. And here Na plus, here -2. So here +1. So here the chlorine is having oxidation. So chlorine has oxidation and as well as reduction in the same reaction. So such a reaction is called disproportionation reaction. An element undergo oxidation as well as reduction at the same time in the same reaction. We call it a disproportionation reaction. Next one, magnesium plus chlorine giving MgCl2. MgCl2, chlorine may be regarded as magnesium combined with the chlorine. The product is MgCl2. So here magnesium is 0, here it becomes +2, here 0, here it becomes -1. So here this will undergo oxidation and a chlorine undergo reduction. So magnesium was oxidized by chlorine. So chlorine is a oxidizing agent. Magnesium oxidized by chlorine. So chlorine is oxidizing agent and chlorine reduced by magnesium. So magnesium is a reducing agent. reducing agent. So you have a clue here. Here oxidizing agent has reduction and reducing agent has oxidation. Oxidizing agent has reduction and reducing agent has oxidation. So please remember, oxidation is mainly for reducing agent and reduction is mainly for oxidizing agent. So here magnesium was oxidized by chlorine. So chlorine will act as an oxidizing agent. We will see the equation. Oxidizing agent, reducing agent, catalyst, providing inert medium. So here the answer is chlorine is a oxidizing agent and magnesium is a reducing agent. An antioxidant used to prevent rancidity in food is. Antioxidant. See, every day, nowadays the students are very familiar and they are using Lay's, Kurkure, then Bingo, I don't know the names. So a lot of packet chips are nowadays available in packets and they are prevented from rancidity. So in your home, when your mother made chips for the Onam vacation, once you take the chips and you have to close the vessel very tightly. Otherwise, what will happen? The crispy nature will be lost and the oil present in the chips will get rancid and the taste will be lost. So the mother will ask you to properly close the vessel where the chips was kept, or the chips vessel should be an airtight vessel. So once you take the chips, you have to close it properly to prevent the entry of air. If air enter, what happen? Rancidity may happen. So like that, when the chips were prepared and you are using the chips after 2 or 3 months, so until then it should be crispy and it should not be rancid. For this, we have to prevent rancidity by adding a material called antioxidant. So one of the antioxidants, there are 2 antioxidants. One is called BHT, and the other one is BHA. And BHT is called butylated hydroxytoluene. Butylated hydroxytoluene, and the other one is BHA, butylated hydroxyanisole. Butylated hydroxyanisole. So here the answer is this one, butylated hydroxyanisole, and another one is sodium hydroxide, it is not added, and methylated hydroxyanisole, that is not added, and sodium carbonate, it is not added. So sodium carbonate is actually washing powder. If you add this is in chips, what will happen? You have to go and sit in the washroom for a long time. So butylated hydroxyanisole or butylated hydroxytoluene. So these are the 2 antioxidant, butylated hydroxyanisole, and the first one is butylated hydroxytoluene. These 2 are called antioxidant. So antioxidants are chemicals added into food material to prevent the oxidation and to prevent the rancidity of the food material. So I request you, don't eat that much of this type of packet food because they contain a lot of chemical like antioxidant. They contain a lot of preservative like sodium sorbate, potassium sorbate, sodium oleate, then parahydroxybenzoate and sodium benzoate. A lot of these preservatives are added in this, and lot of coloring materials are added, and lot of antioxidants are added. So the total lot of chemicals are present in this type of food. So I request you, try to avoid such type of food in your everyday life. Once you take that Lay's or like the chips, because normally we will get attracted by the advertisement given by the celebrities, but it contains a lot of chemicals, and these chemicals are harmful for our health, harmful for our body. So my humble request is, try to avoid such types of, and ask your mother to prepare chips. You eat that chips because it is better than eating Lay's or Kurkure or like that. So don't take it otherwise, because you are fond of all these types of packed foods, but try to avoid packed food in frequently, and once you take it is not a problem, but if you are regularly eating such type of food, it will create obesity and lot of health problem in the future also. So that is why butylated hydroxyanisole is a pure chemical. And next one is zinc solid react with the sulfuric acid to give zinc sulfate and hydrogen gas is an example of zinc solid react with the sulfuric acid H2SO4 dilute the product is ZnSO4 solution or aqueous plus hydrogen gas. So this is another preparation of hydrogen gas. So this is an equation of word equation, symbol equation, unbalanced chemical equation or skeleton equation. This is an equation of symbol equation because all elements are given in the form of symbol. So this is not a skeleton equation. Skeleton equation is this: Zn2 plus 2H plus giving Zn2 plus H2. This is called a skeletal equation, and this is a balanced equation. So this is not unbalanced. This is not word equation. Word equation is this: zinc react with the sulfuric acid. Zinc react with the sulfuric acid plus or giving zinc sulfate plus hydrogen. And this statement, the first one, is called a word equation, and this is an example of a symbol equation. And the next one is Fe2O3 plus hydrogen giving Fe plus DH2O. The values of A, B, C are, we are going to balance the equation. Fe2O3 plus hydrogen, the product is Fe plus H2O. Fe plus H2O. So here we have 2 Fe. So we will put here 2 Fe here, 2 Fe here. Then hydrogen we have 2 and there 2. Here oxygen is 3. So here we have to put 3 H2. Then here we have 3 H2O. So 3 H2O. So we'll see the equation. We'll see whether it is balanced to 2 Fe, 2 Fe. Here 3 oxygen, 3 oxygen. 2 3s are 6 hydrogen, 6 hydrogen. So here this is 1 and this is 3, this is 2 and this is 3. So here the answer is option C. So this is the way in which you have to balance. So 2 Fe, 2 Fe. Here 3 oxygen, there also 3 oxygen. 2 3s are 6 hydrogen, here also 6 hydrogen. So left hand side and right hand side are equal. So 1 3 2 3. So the option is C is the option. And next one, FeSO4 plus X giving Na2SO4 plus FeOH twice. FeSO4 plus X giving Na2SO4 plus FeOH twice. So here Fe is there, the other side Na. So here no Na. So we have to take this one, that is NaOH. NaOH is the reagent. So I'll write the equation FeSO4 plus 2NaOH. The product is Na2SO4 plus FeOH twice. So you see the 2Na, SO4, SO4, Fe, and 2OH, OH twice. So the answer is 2NaOH or simply NaOH. NaOH is sodium hydroxide. Ferrous sulfate combined with the sodium hydroxide, product is Na2 sodium sulfate and ferrous hydroxide. And ferrous hydroxide is a pale green precipitate. Pale green precipitate. Precipitate is represented by a downward arrow. And the next one, the following reaction is used for the preparation of oxygen in the laboratory. The equation is this: 2KClO3. It is called a potassium chloride. Potassium chloride. Potassium chloride on heating converted into potassium chloride and oxygen. 3 oxygen. And for this we normally add some catalyst called MnO2. Here it was not given. So you heat potassium chloride. The product formed will be potassium chloride and oxygen. So it is a decomposition reaction and endothermic, and it is a combination reaction. It is a decomposition reaction accompanied by release of heat. It is a photo. So answer is it is a decomposition reaction and endothermic, because on heating you are getting oxygen, and a KClO3 decomposed to give KCl and oxygen gas. So KClO3 is called potassium chloride. It decomposed to give potassium chloride and oxygen. So it is an example of decomposition reaction, and for this decomposition reaction we have to supply heat. So it is an endothermic reaction. Endothermic. So answer is option A is the answer. The next question. Which of the following reaction will not take place? Will not take place. Zn plus FeSO4 giving ZnSO4 plus Fe. 2Ki plus Cl2 giving 2KCl plus I2. That will take place. 2NaCl plus Br2 giving, and this is not possible because bromine is less electronegative. Bromine could not displace chlorine from, this is not possible. Not possible. Not possible. Because bromine is less electronegative, it could not displace more electronegative chlorine from its compound. So the first one will take place. First one will take place. This will take place. This will take place. And this will also take place. And this will not possible. So not possible is option C, because bromine is less electronegative and in NaCl chlorine is more electronegative. Less electronegative halogen could not displace more electronegative halogen from its compound. So this reaction will not take place, or it is not feasible. And next one is matter can neither be created nor be destroyed in a chemical reaction. Total mass of elements present in the reactant and the products are same, and the total mass of element present in the reactant. In other words, the number of atom in each element remains the same before and after the chemical reaction. Hence, we need a balance, a skeletal chemical equation, which law states that mass can neither be created nor be destroyed. So, answer is law of conservation of mass or matter, that was given by Anthony Lavoisier. Total mass of reactant is equal to total mass of product. Matter can neither be created nor be destroyed. Or total mass of the reactant will be equal to total mass of the products. So that is called the law of conservation of mass. So that is here. And the 13th one, the chemical equation given below shows the reaction between zinc metal and silver nitrate. Zinc plus silver nitrate giving zinc nitrate plus silver. Which of the following represents the balanced chemical equation for the above reaction? Zinc react with the silver nitrate to give. So here the answer is option C is the correct answer. Option C is zinc react with the 2AgNO3. The product is ZnNO3 twice. So here you have one zinc, here also zinc. 2NO3, here 2NO3, 2Ag. So this is a balanced equation for the equation zinc plus silver nitrate giving zinc nitrate plus silver. So this is an example of a precipitation reaction, or this is an example of a displacement reaction, because silver was displaced from silver nitrate by zinc. More electropositive metal displace less electropositive metal from its compounds. So this is an example of a displacement reaction also. So this is a balanced equation. And the next question is, so the question is over. So I hope you understand what I have told you in my class, and please go through the chemistry topic and you will find chemistry in your everyday life also. So a lot of chemistry topic you have to study in your future. So I wish you all the best. Thank you. Thank you.